Morning, guys.
Huh?
Either you all care about hybrid storage or this was the only place you wanted to chill before you took for the airport. Either ways, I'm super excited to have you guys here. I'm Asa. I'm the GM for the Storage Gateway Service. And I'm joined here with Abdul from Kellogg's and Paul, the product manager on the service. So look forward to telling you a little bit about hybrid storage and how Storage Gateway helps solve that problem. We'll give you a little bit of a perspective on hybrid storage because over the last several months, we've seen an increasing number of use cases that customers like yourself have been using the Storage Gateway for. So we thought we'll give you a little bit of a perspective on that. Then tell you some of the new things we've done for the Storage Gateway service over the last 12 months or so since we met at reInvent last year. And then Abdul's going to tell us about how they have been using Storage Gateway at Kellogg's to solve some of their hybrid storage problems. And then Paul will go into a deep dive. For this session, we'll focus specifically on a deep dive of the file gateway, partly because we did a couple of deep dive sessions on tape earlier this week, and I'll show you the sessions you can review later on YouTube. And we've also done several chalk talks on volume gateway, where we went into a lot of the details there. So because there's 3 gateways, there's a lot of material to cover, we decided to focus the deep dive here on, on file and some of the new features we built up on file gateway, especially around content distribution and collaboration workflows. And then we'll leave some time for questions at the end. So when we think of hybrid storage, it's really about connecting data and applications that are on-prem with storage and services in the cloud. So it's when these two are on different places, how do you connect the two to give a seamless experience? And we've seen a range of use cases that fall into this category of hybrid storage. The original use case that customers started using Storage Gateway for, and still do today, is backup. And that's usually a very simple starting point. You have your applications on-prem, you want to back up that data, start using the cloud to back it up so that it's available, durable, easy to access, easy to restore, and so on. So that becomes a starting point, and all 3 types of gateways, file, volume, tape, are available to back up whether, files, file systems, databases, on-prem volumes, et cetera. As customers have started getting more and more familiar with backup using the gateway, backing up on-prem applications and data, the next use case we see is more around tiering of storage. So a lot of times we see customers tell us that our on-prem NAS was filling up. Some of that data was cold. So we used the gateway to tier that cold data to, say, S3, so that the local NAS was still available for hot data. And because the data is moved through the gateway into AWS, they can still retrieve it very easily when they do need access to that cold data. So the tiering of data becomes the next use case. In other cases, we have customers that want access to that data from both on-prem and in the cloud. So you can access the data from using standard file storage protocols on-prem, but also have access to it in cloud to run cloud-enabled workflows. So that's the dual protocol access, and we'll show you some examples of that later as well. Another common use case is low latency editing or low latency access to applications, to data on-prem. So in a number of industries like media entertainment or in the life sciences, customers have e-notebooks. In all those cases, the data needs to be available locally with low latency, but you want to have a durable copy with long-term retention in the cloud. And that, again, becomes another use case, which is quite common for the Storage Gateway. And then we'll talk about content distribution, which is some of the newer capabilities we've built up over the last several months, really hearing feedback from you. When we built the Storage Gateway earlier, we never thought of using it for content distribution or collaborative workflows. And through some of the capabilities we delivered through the file gateway, we saw customers starting to use that for such use cases. And that's, Paul will go into some specific details on that as well. Now, the hybrid storage problem is a difficult one. You know, at the end of the day, you're bridging stuff on-prem with stuff in the cloud. And we try to highlight some of the key problems here. So when you think about the on-prem side, you have existing applications. So you cannot, in most cases, make changes to the apps. So you need to have a paradigm that works with existing applications. But at the same time, in the cloud, you need to be able to work with the paradigm from cloud storage. So there is an impedance mismatch that needs to be addressed. The second problem is, as I mentioned earlier, you often need access to that data from on-prem with low latency. And you need to be able to process that data in the cloud efficiently as well. So again, you need ways in which you can have access to this data from different protocols, different storage services. The third challenge is specifically related to, as enterprises start thinking about using the gateway, it has to fit into their management infrastructure, their existing operating environments on-prem. Some have virtual environments, some have specific firewall rules, DNS rules, et cetera, that need to be addressed. But at the same time, a lot of these workloads are also moving to the cloud. So customers are getting used to KMS, CloudWatch, CloudTrail for managing their in-cloud processing. So again, there's another need to bridge the gap between the two worlds. And then the last problem is the hybrid problem is one where the network between the customers on-prem and the cloud is really sometimes variable. Sometimes you have changes in bandwidth. In many cases, you have many customers trying to access the same data, so you don't want to keep pulling that data back downstream. So there is a need to optimize the data transfer between on-prem and the cloud as well. So these are sort of the key technical challenges that we've been refining our solution to address. So what we do with the gateway is really bridging the two here. So as you saw, the red and the green shows that there was a problem, and here's our solution for that. So the first thing we've done on the gateway is offer a number of standard storage protocols. So you can use NFS, SMB, iSCSI, things that are commonly used in the enterprise world to access the data. But on the back end, the data is stored in multiple storage services, S3, Glacier, EBS, et cetera. So that allows you to use existing applications, no changes, but at the same time access the data, the properties of the data that gets stored in the cloud. We do have a low latency cache on the gateway, which provides access to frequently used data with low latency while we still keep it in the cloud. And especially when we've delivered the file gateway, we store the data in the cloud in native object format. And because of that, you then get access to all the cloud-native capabilities. So you can process the data using Lambda or ML or lifecycle policies and so on. So that, again, gives you the benefit of having the data accessible both from local applications perspective as well as in-cloud perspectives. And then the third thing that we've focused on is the manageability and the deployment options. So on-prem, you have, we've delivered multiple configurations, so you can deploy it on physical, virtual hardware, virtual and physical implementations. And in the cloud, it's all integrated with all the cloud monitoring management capabilities. So it's thought of as a service, even if it's deployed on-prem. And then we'll tell a little bit more later about all the optimizations we've done in terms of minimizing the data that needs to be transferred between on-prem and the cloud. So that's really the value prop of the gateway. And not only have we as a service seen a huge increase in adoption of the storage gateway, I think there's also an increasing awareness in the industry that this is a growing problem as more and more customers are starting to move to the cloud. And this was Gartner's comment on there's a renaissance in the need for storage gateway. And we've seen customers through the entire life cycle. There are customers who just start using the cloud and use backup as a first use case, and then there's others who have already migrated to the cloud and want low latency access, and then they start using the gateway to access their data on-prem. For those of you that may not have a deeper understanding of the storage gateway, this is a one-slide summary here. On the left is the storage gateway appliance, which is either a virtual or a physical component, and that's typically deployed on-prem. We also have EC2 gateways, but these gateways essentially operate within the customer's application environment. We have multiple interfaces, file, volume, tape. And then on the right side is the second part of the service, which is run inside AWS, and that's what completes that impedance match that I was talking about earlier. And the service part of the storage gateway then writes into S3 or Glacier and EBS, depending on the type of gateway that you're using. Speaking of types of gateways, we have three specific categories within the storage gateway family. The file gateway provides file-based access to objects in S3. The volume gateway provides block-based access when the data is stored in S3. The additional nuance on the volume gateway is the fact that the data gets stored, can also be mapped into EBS snapshots. So you can then create EBS volumes and get access to the data for in-cloud recovery for applications such as disaster recovery. And the tape gateway is essentially a replacement to your physical tapes. So you can essentially migrate your tape-based workflows into data being stored in the cloud. Again, a quick summary, the service is designed to be used on a pay-per-use basis. So we have 2 dimensions of pricing. All the storage is priced at a pass-through of the standard storage cost. There is no additional overhead on that. And then we charge for data transfer between the gateway and AWS. And it's 1 cent per gigabyte, capped at $125. So it's really designed to be cost-effective on a pay-per-use basis. And we have a number of compliances to, and security postures as well. The service is available worldwide, all public regions, and we also made it available in GovCloud earlier this year. A little bit of an eye chart, but just a quick summary. We have been busy over the last 12 months. We had 15 launches since last reInvent across all types of gateways. The ones that are worth just reinforcing here in case you missed the announcements as we did them over the course of the year, we added SMB support on File Gateway. We introduced the service as a hardware appliance, and if you walked over the Expo, you may have seen the server sitting in the AWS booth, so you can now also deploy it as a hardware appliance. And we've done a fair amount of work in improving the performance of the solutions as well, and I'll talk about that in a couple minutes. Some of our customers, they range from all types of segments, all stages in their cloud journey, all sizes of customers, and we're super excited that we are really solving this problem for mapping on-prem services into the cloud. Just a quick couple slides to refresh folks on the specific features of file volume and tape gateway. So the use cases for File Gateway are typically backing up for on-prem databases or in-cloud databases. File also has opened up a number of new use cases around hybrid architecture. So we have a number of customers that use File Gateway to upload data into the cloud, get a notification when the data is uploaded, and then use that to trigger workflows, whether it's a Lambda function or recognition jobs. Some of you may have seen the Builders Fair, where we showed a demonstration of dropping images on the File Gateway, running recognition, and you can then create workflows based on that. I talked about a number of these features, so I don't want to repeat the features here again, but worth highlighting the performance enhancements that we've done on the File Gateway in the last several months. So you can now have your clients writing at up to 4 gigabits per second into the gateway. And we have several details on our website on how you can achieve the performance, the types of platforms that you can do. And Paul will talk a little bit about best practices to get this level of performance. The tape gateway, as I mentioned earlier, it's designed to be a drop-in replacement to your physical tape-based workflows. So the gateway exposes a VTL interface so that your existing backup apps keep writing to the gateway as if it's a physical tape. But behind the scenes, we map that data into storage in the cloud. And all your tape-based operations get replicated. So when you eject a tape, it gets archived into Glacier. When you restore it, typically you would have had to recall the tape back from your off-site tape storage facility. In this case, you just restore it from Glacier. You have access to it within 3 to 5 hours. So it really simplifies your workflows. And we now support compatibility with all common backup applications. So we just introduced, a couple weeks ago, support for IBM Spectrum Protect as well as Bacula. So with that, we support pretty much all the commonly used backup applications. And you can keep using the apps, use your workflow, and the data is in AWS. On the tape gateway as well, we've done a fair number of performance improvements. You can now write up to 2.3 gigabits per second through your clients into the gateway. Downloads are also faster. It's at 0.6 gigabits per second. And again, Paul will talk more about tuning the gateway for performance. We did a deep dive a couple times this week on tape performance optimization as well that you can look at if you're interested. The volume gateway provides an iSCSI interface, so you can map your volumes to the gateway. These volumes get stored in S3, and you can then create EBS snapshots out of that. So the typical use cases tend to be backing up of on-prem volumes as well as disaster recovery. One of the things that we introduced new for the volume gateway is full KMS support. Obviously, all gateways now support KMS encryption as well. We have 3 platforms available for deploying the storage gateway. The VMware and Hyper-V platforms have been available for a while. Several customers deployed the gateway in EC2 as well. And then back in September, we introduced the gateway as a hardware appliance. A number of customers told us that, while VMs are easy, there are some scenarios where either there isn't enough VMware infrastructure or they just don't have the IT expertise. Maybe it's branch offices, maybe it's the time to procure virtual resources. So we partnered with Dell to offer storage gateway pre-configured on a Dell server. And you can order it from Amazon.com. So you can go to the storage gateway console, pick hardware as the option. You get routed to our retail site, and then the gateway is delivered to you pre-installed. You can even use Prime for delivery. And the value prop, it's simple, it's out of the box. All 3 types of gateways are available. It has dual power supplies, dual NICs, so it's designed to be reliable. And you get much more of a predictable performance if you pick the gateway. It's an out-of-the-box solution. Support, first line of support is AWS, so you would call AWS for support just like you would with your virtual solution. And we can help bring in the hardware partner in case it's a hardware issue. The appliance today is available in the US for all 4 regions, and we look for feedback on other regions that we can offer the gateway hardware appliance as well in. Some of the key feedback that we got after we launched the hardware appliance, it's just easy to set up. It's out of the box. It's simple. And that was really the value proposition we were hoping to achieve with the gateway. The other thing we've heard customers say is it's just managed from the cloud like another AWS service. And I mentioned before that it's connected with CloudWatch, CloudTrail. So with this gateway appliance, you don't need to worry about hypervisor patching, OS patching, updates, etc. All of that is handled through the back end. So I'm going to pause here and hand it over to Abdul, who will talk about his journey to using Storage Gateway.
All right, thank you, Asa. Good morning, everyone. My name's Abdul Mohammed. I work at Kellogg. I'm here to talk about our storage gateway journey, right? This is one of the most important aspects to our cloud journey, as you'll see as slides progress. So a quick show of hands here, right? Who has eaten our product or know about our products, right? Just about everyone, right? We produce about 1,600 different products in 21 different countries, right? It's marketed in 180 countries. World's largest cereal company, and we're the 2nd largest manufacturer of cookies, crackers, and savory snacks. Net sales of about $13 billion. It's a global company. So what were some of the key business drivers for us, right? To list the top 5, right? Agility, right? We wanted something push of the button. We did not want to wait 6 to 8 weeks to do procurement of our hardware, right? Tight margins. A company like Kellogg that spends 1/3 of our revenue in trade promotion, right? Any savings that we do goes directly to our bottom line. Scalability, right? Everybody wants scalability nowadays, right? End-of-life infrastructure. We had a whole bunch of aging infrastructure that we needed to make a decision on. Either we replace the hardware or we move into the cloud. And also as part of this, we wanted to go to a new costing model, right? From CapEx to OpEx, right? We wanted to do more of a chargeback model instead of a showback model, right? I mean, everybody knows IT environments are complex, right? You got your remote sites, you have your database server, file servers, data lakes. many IT teams struggle to efficiently back these up. So I'm here to talk about how we have done that, right? Just like any other company, we started off with migrating our dev and test workload. Initially, we let that bake in few weeks, few months before we could make a decision on either going in production. Back around 2014, we had a great opportunity, right? Our Asia Pac infrastructure was going end of life, right? So we had to make a decision, hey, do we want to move our infrastructure to AWS because we already got dev and test workloads there, or do we want to just go buy hardware and do this build there? So we took the decision. Our VP was nice enough to give us the opportunity to start the migration process. So this was just it was not just a simple lift and shift, right? It was lift and shift plus upgrades. So it was complex. Our database sizes ranged anywhere from 100 gigs to 20 terabytes. So it was pretty decent amount of work. Not only that, right? We also wanted to make sure we have proper backups in place, right? Because this was a new technology. What we had done initially, we started using traditional backup, lift and shift. What was working on-prem, we wanted to do the same thing in AWS. So we lifted and shifted our traditional backup infrastructure in AWS as well. So what did we notice, right? At the end of the project, we noticed our storage and compute costs were going down, but our backup costs remained the same, right? So this was not something AWS, right? That was something that we had to do. So we set out a goal for ourselves to migrate all of our backups and use more of a cloud-native backup, right? We wanted point-in-time recovery up to the second, and then obviously lower cost. So obviously you got our traditional backups, right? You got your cloud-based backups. With traditional backups, you are running multiple master media servers to back up your environment. It's a lot of resources that you got to spin up, right? Not only that, there's a lot of people you need to manage those. There's a lot of caring and feeding that you got to do, patching. It involves a lot of stuff. The biggest pain point for us was licensing. Although the backup was ending up in S3 for us, we were paying per terabyte of data being dumped into S3 to the license vendor. So obviously, for our cloud-native backups, right? We wanted to scale. We wanted to start pay-as-you-go model. We wanted pay-as-you-go model for anything that we do, right? In our older traditional backup, if we had to back up 300 terabytes of database, on day one, obviously, I'm not going to be backing up 300 terabytes, right? It'll be few gigs and it'll grow. But in traditional model, we had to pay those 300 terabyte of licensing. Obviously, we wanted to scale up, and then in a nutshell, our solution was EBS snapshot for daily backup, and then all the transactional log backup for point-in-time recovery using Storage Gateway, right? Sure, you got your daily backup, but if you can't roll forward to a specific point in time, a specific second, you're losing a lot of data. So this is where Storage Gateway helped us out here. So going back to one of the previous slides, right? It's complex, but Storage Gateway works in multiple environments across multiple workloads. So this was our initial architecture. Looking at the right side, the diagram, bottom up, we started using Cache Gateway to begin with for all of our transactional log backup. What we had done, we created 6 32 terabyte volumes, created a logical volume, and it was turned out to be 192 terabyte mount point, and we mounted that across all of our database servers, right? Database 1, 2, and a number of servers. We needed something to be mounted across all of our database servers because we do some cross restores, and we needed that. We needed multiple clients to write concurrently. One thing, at peak, we were able to write 350 gigs of data per hour into Storage Gateway with no issues. So this was a really good thing for us. Our backup jobs actually were 2 times faster compared to traditional backups, right? We eliminated the whole master media kind of scenario, backups are going through EBS Snapshot, and transactional logs were going directly into Storage Gateway. We put together some quick scripts for our to reduce our RTO, right? We are able to bring up our Storage Gateway in less than 10 minutes. These are some quick Python scripts, some simple API calls. To meet our RPO, right? We were sending snapshots from one region to another region every other hour. This was kind of pushing the boundaries for our end for our RPO, right? So the next design that we put together, right? Because the reason why we switched from cache gateway to file gateway was because of our RPOs, right? We had scripts that were copying snapshots from one region to another region. We didn't want to be in the business of managing those snapshots. So with file gateway, right? When backup ends up in S3, S3 is taking care of replicating that over to DR region. This was pretty significant for us, right? Our RPO went down from 2 hours to 15 minutes. This was a pretty big thing. And then our backup times were increased again, right? 2.5 times faster than volume gateway. And the reason for that was we eliminated the NFS layer that we had. And then I can attest to this. File gateway has been set and forget infrastructure for us. We've been using that for about 8 months in production. I don't even know when was the last time I actually logged into the console or looked at anything regarding file gateway. It works even during patching time. There's nothing that we have to do. The storage gateway team does an awesome job here to take care of all that stuff for us. And then obviously encryption on by default for us. And then lifecycle policy, one thing is the compute team had more control over when we could expire backups, right? Because all other teams were taking care of backing up into the gateway. We had to make sure that there's a point somewhere where we can say, after X amount of days, you gotta delete the backups, right? So we had more control over that. A few other use cases that I can talk about that we use. On-prem SQL Server backups, right? We have quite a few database servers as part of our cloud migration journey. We wanna archive those. File gateway helped us here, right? Excuse me. Obviously, once we backed it up, we had S3 lifecycle policy that pushed it to Glacier. But the best part here about this was we were able to do native SQL Server restore back into EC2 and RDS. So that's a really good thing. This also is going to be part of our migration journey, right? When we start migrating our SQL Server backups, we're going to use this as one of our migration paths. 2 other use cases. So we have a Hadoop cluster running inside EC2. We manage that. But the data gets written to S3 via S3A connector that Hadoop provides. But what was happening was all the Hadoop-related products, right? Hive, Pig, Ranger, and all those things. They're able to see that data, but we had some legacy third-party application that needed to read and write that data, right? It needed to be POSIX compliant. Instead of rewriting the whole thing, right, we could have written an application to read data in and out of S3, but we just stood up a simple file gateway. It makes all your objects look like it's a POSIX compliant, and we're able to use that. The other thing, this was a pretty big thing for us. We, at one point in time, because of the whole procurement process to get hardware on board on-prem, we were about to run out of storage on our backup device on-prem. So obviously, this is not a good thing, right? Because this will stop all of our databases. It'll hang the databases if transactional log backups are not taken care of. Guess what? Came to the rescue again, File Gateway. We stood up File Gateway, and we had unlimited access to storage, S3. So some of the best tips and tricks from Kellogg's standpoint that we have seen. If your file gateway is running in AWS, EC2, right? use IO1 volume type, right? We started off with GP2, but for us, IO1 seemed to be the best option. You got to play around with the settings, especially now that you got elastic volumes, you can increase or decrease the IOPS if you have to. If your gateway is on-prem, make sure you have separate disks for your upload buffer and your cache volume, right? This will help with performance significantly. For EC2 instance, make sure you have auto instance recovery turned on. A simple thing, simple few click, and your instance will auto recover itself. This is also scripted out on our on-prem server as well. Through vMotion, we are able to move the gateway appliance. Rebalance some of your backup jobs if you're seeing some issues, right? This will help you make sure you got good throughput. The big thing for us, right, if you remember the initial design and the final design, the big reason why we moved away from EBS snapshot of cache gateway to file gateway was what we were noticing at bulk loading time, right? As I mentioned, 350 gigs of data per hour, and we were snapshotting every 2 hours and sending it to second region. 700 gigs of data being sent every 2 hours, right? At bulk loading time. At times, if the snapshot copy did not finish to the DR region, and if you do not have a queuing system and you send another snapshot, the second snapshot is considered as full, right? So in essence, we were sending 192 terabytes of data instead of 700 gigs of data. So something to keep that in mind. And then for folks using Oracle RMAN backups for their archive logs, refresh cache, right? Asa mentioned there is an API call that you can make to do the refresh cache. So anytime we do any of our backup in RMAN for archive log backups, before that, we actually do a refresh cache. Our outcome, was significant for us. 90% reduction in our monthly backup costs, right? Initially, it went down going from traditional backups to cache gateway. We were down 50%. Then going from cache gateway to file gateway again, more improvements, faster performance, 90% reduction in our monthly costs. 40% reduction in our cache outlay. That's our capital expense. That's a pretty significant amount. You gotta remember, the traditional backup systems, the master media, we had to set that up for every single region, right? So that's a lot of capital that we had to put up front. The third thing that came out of this for us was, this was unexpected for us, right? Because we were not doing backups directly on the server, we had reduction in our compute resources. And due to that, the database servers, we were able to reduce sizes down from extra large instance type to large, right? So more savings. So what does the future hold for us? We have multiple gateways running, right? We want to consolidate that into one, see how that behaves. We are in process of migrating, so we are going to have larger footprint in AWS. And then we are excited to try out the storage gateway hardware appliance, right? This was a big thing asked for us, and we are going to give this a try. For our SAP instances, we run a lot of HANA instances. We are already using X instance, and we are going to be using, start to use U instance type. And then one of the big asks that we have from the gateway team is high availability of these appliances, right? I think that's all the slides I got. With that, I am going to hand that over to Paul.
Thanks, Abdul. Thank you. It's always great to see our customers' journey and what the service can do to help them. So thank you for helping out and sharing your story here.
Absolutely.
Before I get going, can I get a show of hands for how many people have used Storage Gateway? And in particular, File Gateway? Okay, so some folks. Hopefully you learned something here. The idea is to give you a little bit of insight as to what goes on under the covers that support some of these workloads that Abdul's talking about, and give you a few tips and tricks along the way so that if you're deploying it, you can avoid pitfalls and make a better performing hybrid storage solution. So let's start by looking at what your applications see. Again, one of the things that File Gateway provides to your application is the illusion of a file system on top of objects that are in S3. So it provides access to those objects in S3 as if they were files. So what your application sees is either an NFS export or an SMB file share. You get one of those per bucket. You select the bucket during configuration, and that bucket appears as a mount point to your upstream file clients. You can protect that mount point, that NFS export or that SMB file share, either using IP addresses if you're using NFS, or using AD membership if you're using SMB. So if you're using SMB, the gateway becomes part of your domain, and therefore users need to be authenticated to your domain, and we use their domain authentication to control access to the file share. Once the users get into the file share, we then use POSIX permissioning. So again, if you're in NFS, it's standard Linux style permissions or Unix style permissions. If you're in SMB, it's their domain membership that's going to control access to which files, which map to which objects they can see in your S3 bucket. All those permissions that are on the files are actually stored on the objects in S3. They're not stored on the gateway itself. They're stored in user metadata on the objects in S3. So the gateway is effectively disposable. If you turn the gateway off and spin another gateway up and point it at the same S3 bucket, you'll get your file system back. We'll see why that's important in a moment when we start to look at some of these content sharing use cases that Asa mentioned earlier. Also important is that you're really interacting with the cache, and I think Abdul mentioned the importance of having good performant disk behind the gateway. File operations from your client standpoint are interacting with the cache. When they read data, they're going to read it out of the cache. If data isn't in the cache, we're going to fetch it from S3, put it into the cache, and then serve it up to your application. So that's called a cache miss. Your application really just sees increased latency. He doesn't really know that we fetched the data other than the fact it took a little longer to return what he requested. If your application rather writes data, it's going to write data into that cache, and we're going to acknowledge your application that we've got the data. Then we're going to asynchronously upload it. So that's a write-back cache for anybody that likes to use sort of correct terms, I guess. So what's going on in the gateway, and how does this caching work? Because this is, again, a subject that we talk to customers about an awful lot. They think that they fire up their gateway, they create a file share, and it's like, well, how can I see billions of objects on this small gateway that I've only put a couple of 100 gigabytes of cache behind, maybe? So the idea is the gateway will progressively discover your bucket. We don't scan the bucket up front. We discover the bucket as your file-based application performs file system operations. We store that in two sort of segments of the cache, a data cache and a metadata cache. Often you'll explore parts of the bucket but won't look at the files, so we keep these things separately and manage this fully for you. You don't have to worry about what's in cache. We keep basically your working set of data there. When we need space to pull in some more data that's more frequently accessed, more recently accessed, hotter data, we'll evict the coldest data automatically under the covers and pull in the new data. And we'll look at that when we talk about CloudWatch metrics, because you should expect your cache to be fully used, 100% full. If you give us 1 terabyte of cache, we'll use that 1 terabyte of cache. We don't want to waste that precious resource that you've assigned to the gateway. We'll keep as much of your data close to your application as storage we have. Meanwhile, all of your data is stored in S3. So again, the cache is a write-back cache. All of your data is going to move into S3 no matter what happens. It stays in the cache, but we'll store it in S3 for long-term durable storage. Again, so if the gateway gets powered off, or you want to access your data from somewhere else, the data is really in S3. That's the master copy, if you like. We do support up to 16 terabytes of local cache. The minimum is 150 gigabytes. But for those customers that want to keep a lot more of their bucket, we have customers with multi-petabyte buckets sat behind a file gateway. You can keep up to 16 TB of that data cached locally to your application. Important also to note that we don't cache full files. We cache files at a partial file level. What this allows us to do is be really granular with how we manage that data. So for example, if you started to interact with a large file, the example I often give is interacting with large video files. So maybe you have a 1 terabyte raw AK movie, and you only have a couple of 100 gigabytes on the gateway. You can still read and write that full file, even though it's much larger than the size of the storage you have local. The gateway will manage paging bits of that file in and out as you read and write it. We're going to keep data in that cache. Again, I want to stress this because this is a point of question from a lot of customers. We're going to keep that data in the cache as long as we need to, and then only evict it once that data becomes cold and is not being used by your application. Also important is that the gateway is fully under your control. We securely associate it with your account. when you activate it, and you give it a role. An IAM role is on your account. You're not opening up your buckets to a service credential. You're giving us a role, and the gateway is using our secure token service to get a temporary AKS key, a temporary credential to access your bucket. He keeps recycling those credentials. You control the role. If you want to shut a gateway off, you can delete the role or change the role's access policy to your bucket. Now, given that file-based applications at this point don't really know about a lot of the S3 features, but a lot of customers want to have their data land in S3 with some of those features enabled, things like selecting the storage class, things like KMS encryption, things like MIME types and such. We allow you to configure that on a per file share basis. And the gateway takes care of making sure that when we move data into S3, however you've configured data to land in S3 is taken care of by the gateway, unbeknownst to the file-based application that's thinking of reading and writing files. So if you want all your objects encrypted, you can configure a KMS key. You could use S3 server-side encryption with S3 keys as well if you'd rather. You can have us guess MIME types. You can do things like request a pays if you want to use the file gateway to access shared data sets, some of these public data sets. It's another interesting use case, in which case you need to effectively accept the charges for requesting data out of those buckets. So we give you flexibility to control how your applications can access the files on the gateway. We fully manage this cache in the middle, and we give you flexibility to configure how your data lands in S3. Let's take another deeper look at how reads and writes work, because again, this is another point of discussion that I have with a lot of customers. Again, we talked about the caching. When your application writes data to the gateway, it's going to get asynchronously uploaded to S3. Now, given that file-based applications kind of do small reads and writes, and S3 prefers larger puts and gets, we do some aggregation on the gateway in that cache to more efficiently move data between your gateway and S3. If your file is large, we'll manage doing a multi-part put into S3. We highly parallelize those, again, just to get that efficiency of data transfer between the gateway and S3. If your file is small, we'll do a single put. So for those people who are using e-tags to do checksum validation of their data, the e-tags should all match as you would expect. We do validation in flight, again, using S3's best practices around MD5 checksumming of puts and checksum validation of those. Again, the gateway is just going to do all that under the covers for you. You don't have to worry about it. Another important consideration is that we use copy put, and this is really important when you think about how S3 works versus how a file system works. When you put an object into S3, you write it once, and you can read it lots of times, but you can't mutate it, you can't change it. But files can be constantly mutated. So what the gateway does in that instance is it takes the mutation that you've made locally on the gateway that we store in the cache, we upload just that data to S3, and then we use S3's copy put capability to reconstitute the mutated file, or the mutated object in that case, and put it in place on top of it. So in this case, you can, again, go back to my 1 terabyte movie file. I could append 1 byte to that movie file. The entire movie file, terabyte file, is not really on my gateway. I'd upload 1 byte, a little bit more because you've got HTTP headers, and then that whole now 1 terabyte plus 1 byte file would get rebuilt on the server side. So it wouldn't waste your bandwidth. We take care of that all on the back end, all on the S3 side. So really neat, really efficient way of moving data into S3 and mutating objects. Again, other file system operations like renames and those sorts of things from a file-based application standpoint happen as they'd expect. A rename is an atomic action. Everything gets renamed. We handle on the back end the fact that S3 doesn't do renames. We have to do a whole bunch of copies and a whole bunch of deletes. So we manage all of that on the back end. And S3 being eventually consistent, you'll eventually see the same data sets in S3. Reads, I mentioned, are synchronous. So again, if you're going to read data straight out of the cache. If you get a cache miss, and we'll look at some of the metrics, CloudWatch metrics that we provide in a moment that'll show you what's going on in the cache. If you get a cache miss, we'll pull the data into the cache and serve it up to your application. We try and do, again, minimal transfers down to the gateway as we can, and we've got a little heuristics in there. So we do byte range gets, obviously. Again, my 1 terabyte file through a much smaller cache will get the bits of the file that your application's reading. If it's a video, you're streaming bits of that file in. And we'll do a little bit of predictive look ahead, a little bit of prefetching of data. So if we see certain file operation patterns, serial read is a very common one, we'll start to prefetch that data to stage it in the cache ahead of your application requesting it. So that makes it a little more efficient. Again, your application doesn't suffer that first byte latency. To pull data into the cache, we potentially staged it already in the cache. Again, I mentioned earlier that we have this difference between a metadata and a data cache. Super important for file system operations. So on the left there, we see like a dir and ls list directory in Windows and Linux systems there. You want those to be snappy. You want those to be responsive. So we keep a cache of the metadata on the gateway separate from the data cache of the actual files that you've read. And in this instance, we're mapping that to a list bucket. So if you list a directory, that's a logical equivalent of S3 of a list bucket. So we list bucket with prefix. That helps populate that cache. And we'll do that on demand. Again, we're not going to go in and read the entire namespace of your bucket, the entire key space of your bucket up front. We'll pull that in, page it in as your application needs it to be most efficient. And again, we're going to keep that cache and recycle it and manage it for the hot data sets, the hot metadata that your application needs at that given point in time, and free up space when newer data becomes more interesting to your application. And we mentioned a couple of features. Asa mentioned a couple of features that we've recently added over the course of this year to make the gateway more a component within active workloads rather than just sort of a file server sat there. So we've added a couple of capabilities, a couple of API calls that allow you to trigger CloudWatch events when the gateway performs an operation or finishes performing an operation. So in this instance, we have an API call called notify when upload. So if you go back to how I was mentioning how writes happen, it's a synchronous write into the cache and then an asynchronous upload. Now, if you have a workload in the cloud that's waiting on that data, how does it know when it can begin processing that data? Because it's not when the file-based application finishes writing it, it's when the transfer is complete over to S3 over whatever connectivity you have. So we have an API call that you can make to the gateway, or to our backend that then talks to the gateway to let you know when that data is available in S3. That'll be served to you as a CloudWatch event. You can take that CloudWatch event and connect it to spinning up your application. So it allows you to orchestrate workloads that are generating file-based data on premises. Maybe you have devices in your lab or processes running on-prem. Drop them into the gateway as a file, have the gateway take care of getting them into S3 as objects, and then fire up your workload in cloud. You don't need to guess when the data is going to be there. You don't need to time it and assume it's going to be there. You can use CloudWatch events to orchestrate that end-to-end workflow between the file-based generator and the in-cloud processor. Kind of a diagram of the same thing. Again, given that we're now talking with objects directly in the S3 bucket, you can use a lot of those services that are directly integrated with S3. They talk S3. They talk S3's protocol rather than file-based protocols. Asa mentioned earlier this idea of dual protocol access. You can access them as files. You can access them as the same data as objects. Another capability that we added earlier this year, and we've enhanced just recently, is called refresh cache. So I've talked a lot about how the gateway is aggressive about caching data to give that responsive file system experience to your file-based applications. Now what that means is if you generate data and put it straight into S3, perhaps that workload that we talked about generates a result set and drops it back into your S3 bucket, how does the gateway know about that piece of data? He's got a cache and he's explored the namespace. Well, we have an API call that you can make, again, to do the standard AWS SDKs, a CLI, which will tell the gateway, hey, there's stuff in the bucket that you're exposing as a file system that may have changed. Go validate your view of the world and the bucket's view of the world. And he'll do a refresh cache. He'll do some of those list operations in order to make sure that his namespace and his data space is the same as what's now in the S3 bucket. The enhancement that we've made to this recently is to allow you to do this by prefix. So again, a lot of S3 operations happen by a prefix. And so that means that you can be really efficient with telling the gateway which parts of your key space in your S3 bucket may have changed. Again, the gateway, because of how your file-based application may work, could know about millions of objects within your bucket, of the potentially billions in your bucket. Not all of those have changed, so why have it go explore and make sure that all millions of those objects are still in your bucket and still up to date? Your generating application that's dropping data in S3 knows which key space he dropped it in. He knows the prefixes perhaps that he used to put result sets in. And so you can tell the gateway to just validate and just refresh those parts of the key space. Makes it much faster in terms of the gateway's ability to take those objects and service them back as files, and therefore make that data available to your on-premises applications. Also reduces the number of S3 requests that need to get made on your behalf by the gateway. And at the end of the day, when the refresh is complete, we'll also issue you a CloudWatch event so that you, again, could orchestrate a workload that cares about consuming that data in S3 as files. He can also be automated in order to pick those files up because they're now available to him after the refresh cache is complete. Let's look at a couple of use cases where some of these features of the gateway come together. So a common use case that we're seeing from customers these days is I have a single source of truth, a single source of data in my S3 bucket, and I want to support that with multiple gateways. I have maybe 2 different gateways from 2 different labs or 2 different facilities. They want to be able to stockpile data, if you like. It could be data lake as the, you could be trying to build a data lake. I want to stockpile that data in one S3 bucket. In this case, you can have 2 gateways pointing at the same bucket. Now, the challenge with doing this is that S3 is an eventually consistent object store, and the gateway is trying to present a POSIX-compliant file system to your applications. The gateways don't communicate to each other, so you have to be careful to make sure that they're reading and writing to a separate key space within your S3 bucket. And this is no different to what you would do if you were building an S3 native application. You want to avoid 2 applications trying to compete or fight over the same key because it's eventually consistent. So you could get unpredictable results if they were to both write to the same object at the same time. So with Gateway, the way that we recommend to customers to do this is to just pick a prefix and have the 2 gateways mount a prefix within the bucket so that you know there's going to be no key collisions. Because again, the file-based applications know nothing about the S3 stuff that's going on under the covers. So it's important to help them not do the wrong thing, if you like. The disadvantage of this use case, obviously, is that these 2 gateways are looking at separate key spaces. So while there's one source of truth, one bucket on S3, they really think of these things as 2 separate file systems, and they can't share data between them. So if you had users that were connected to File Gateway A, rather, and users connected to File Gateway B, they wouldn't be seeing the same data sets. They each have a separate tree. Kind of obvious, but worth pointing out. If you want users to see the same data, we have the ability to create read-only exports, so controlled at the gateway, that you have a writer and potentially multiple readers. So you're not trusting that the clients are going to do the right thing and not write to the same key space. You're controlling it within your configuration of the file shares. And this is something that we see a lot of customers do in order to make data available around the globe, potentially to multiple offices, where each office will have a writer, and then the other offices will have a reader, a read-only gateway. And they can all point at the same bucket and see the same data. And again, using things like refresh cache, those gateways can keep up to date with what data is in S3 as the writer puts data in. Again, sort of another flavor of the same thing. The gateway is going to read data from wherever that bucket is. And therefore, the latency of reads is impacted by the ability of the gateway to get data from that bucket. So for example, if you're doing this geographic distribution of data, it may be beneficial to you to use something like cross-region replication and keep the bucket close to the gateway. For example, you may have one office in, say, the East Coast of the United States, and maybe you'd have him reading and writing data from a bucket that's located in that region, and then your other office may be down in Sydney, Australia, in which case you could do cross-region replication down to a bucket in Sydney and have a gateway down there that's talking to that bucket. Again, they'd see the same data sets. Cross-region is taking care of making it more local to the gateway. Then the gateway's latency for reads is going to be dictated by the gateway's ability to get to that bucket in Sydney, rather than the gateway's ability to get all the way back to the East Coast of the United States. Let's take a segue and talk about best practices on performance. I know Abdul's done some work on this on some of the EC2 side of things. And again, I'm going to echo some similar findings or similar recommendations that you've implemented on your side. If you're running a gateway on premises, again, I talked earlier about how caching works. The performance of your reads and writes are going to be very much dictated by the performance of the disk that we're putting data into and getting data out of, just as any other on-premises file system. So running good NVMe SSDs is going to be helpful for you if performance is something that you need from the gateway from a read and write performance. Splitting the cache across multiple disks also helps. Internally, it helps us parallelize some of our I/O, especially if you're going to spindles, it's going to help. And again, if you're in cloud, if you're in EC2, or hypervisor allows you to play with these things, adjusting IOPS and watching that at a I/O level is also going to be super important to you. Parallel is also another one. Either multiple applications, multiple gateways, parallelizing your reads and writes. We see a lot of customers that call in where they are having performance troubles, and it turns out their application is using a single serial writer. It's like, well, you're only going to get as fast as that serial single writer can write data. If you can parallelize it, either multiple writers or parallelizing your application or spin up multiple instances of your application, you're going to get better performance. It sounds obvious, and it is. Nothing magic there. That's just the way of the world. We also see customers that are trying to perform workloads that they can benefit from multiple gateways. we don't charge you for a gateway. It's a pay-per-use service. You can spin up multiple gateways and use a scale-out approach also to increase your overall performance. Let's look at some of the metrics. And again, another area that I talk to a lot of customers about is, I see this gateway, my applications are writing to it, I see my data in S3, but I don't really know what's going on. So we provide a lot of CloudWatch metrics. I think we have 18 in total. I'm going to talk about a couple of them, a couple of ones that I think are the most important here to watch while your applications are running to understand really what's going on. So you can understand your client performance by looking at write bytes and read bytes. That's the ability of your application to write data into the gateway, take data out of the gateway, kind of obvious. You can understand how quickly your gateway is able to send data to S3 using Cloud Bytes uploaded and Cloud Bytes downloaded. And again, in CloudWatch, you can see these things as graphs, as time series. You can aggregate them, all the usual things you'd expect from CloudWatch metrics. Maybe a little more unusual or a little more interesting here are the ones we provide around the cache. So we provide one called cache hit percent. Now, you'd expect that to be high. You want that to be high, rather. You want it to sit as close to 100% as you can. That means all of your application's reads are coming from the cache. Obviously, as workloads shift, you're going to see it drop a little bit below 100% as new data is paged into the cache, but you want it to be high. Then you'll get the best performance. You're not fetching a lot of data from S3. Many of our customers set a CloudWatch alarm at sort of 80 or 90%, and if it persists below that, they start to look at what's going on. Maybe my working set has changed. Maybe my cache isn't large enough, and so I'm constantly cycling data into and out of the cache. Cache percent used, I mentioned earlier. You expect that to hit 100% once your gateway sort of hits steady state. A lot of customers get super concerned and we get a call into support. They go, my cache is full. How do I free up some space in my cache? We're going to take care of freeing up space in your cache. We're going to use all of the disk you give us. You've spent good money on it. Let's make good use of it and keep that data close to your application. We'll manage the cold data out of there as hotter data comes in. You'd expect it to sit at 100%. Cache percent dirty is an interesting metric because it's an indication of how much data is sat in the cache that is waiting to be uploaded. Again, I mentioned that asynchronous upload to the gateway. So again, you expect that or you want that to be low because that's data that's in flight. That's data that's not yet stored in S3. So again, many customers configure a CloudWatch alarm on that at say 5% or 10%. And that gives them a warning that maybe something's going on. Maybe my application has just dumped a whole bunch of new data into my gateway and I'm struggling to upload it because I have a bandwidth problem or a networking problem upstream to get that to the cloud. So again, you want to set an alarm and look at cache percent dirty as being something low. You want a low amount of data in the cache that has not been uploaded to the cloud, uploaded to S3. I'll quickly cover storage classes because I'm just looking at the clock. We have a lot of customers that want to use S3 capabilities like Zyphal. The gateway is an S3 client, so you get the same behavior you would with an S3 client going directly against S3 in terms of if you're using things like infrequent access. So you will see retrieval fees. Again, the file-based application may not be aware that it's really interacting with an infrequent access class, and so you may see unexpected retrieval fees. Again, for most users, we recommend that you actually configure a lifecycle policy to move the data after, say, 30 days from standard down to infrequent access, and that allows your file-based application to read and write the data with impunity, and then once the data is stable, it can get cycled down to IA for that lower cost. I'm going to wrap there because we have no time and I've talked too long. Thank you for coming. We just wanted to end on sort of covering up our storage portfolio, our transfer portfolio, and hybrid storage portfolio. We have a number of services. If anybody was in Andy's keynote that saw that. We did introduce 2 new services, Data Sync and Transfer for SFTP this week. We think of those as online data transfer services. We obviously have our Snowball family of products for doing offline data transfer. Then Storage Gateway fits in that hybrid storage. Once your data's in the cloud, you still want to access it from on-premises. Storage Gateway provides you a way of doing that. Thanks for coming, and if anybody has questions, we're happy to take them. And I do have stickers if anybody wants to.
Thank you. What is the behavior of the gateway if the network between the gateway and S3 is slow or down for reads and for writes?
What's the behavior of the gateway if the network between the gateway and S3 is slow? Okay, so the gateway is the behavior of the gateway is that your client would go to read some data. You'd get a cache miss, so your cache percentage would drop. We'd go and do a get from S3. Again, we're going to try and get as little data as we can. The latency of your application's response to get that data is going to be dictated by how quickly we can get it from S3, drop it in the cache, and serve it up. If there's no network connectivity at all, your application's going to hang as it would with an NFS server of not able to get data. And then eventually, if the network never comes back, you're obviously going to get a network disconnected error. Yeah, please.
Hi. I was wondering, can I connect a storage gateway on-prem to AWS over a direct connect connection?
So can you connect over a direct connect? You can, but you require a public VIF right now. So the service doesn't have in VPC endpoints. We have public endpoints right now. So you'd require either a public VPC on the other end of your direct connect or a VIF to get you out to the public endpoints.
Previously, one of the differences between the volume gateway and the file gateway was that the volume gateway would do block level replication and deduplication. One of the things you talked about was that you've reduced the file size between, or the difference in the gets and puts from the file. Does that mean that from the file gateway, does that mean it is now deduplicating as you're doing the uploads and the changes to the file system?
So with File Gateway, we do no compression, no deduplication. We want your files. You have a file called test.txt on-prem. We want that to be an object as test.txt, because that then allows you to get downstream value for that data once it's in cloud. If we were to deduplicate it or make it opaque, you wouldn't be able to use it natively in the cloud. For our Volume Gateway, because the volume's kind of a block device, we do have some efficiencies of how we can store that for you. And then we rehydrate that when we create the EBS volume or the EBS snapshot from that volume when you choose to create the snap. So with our volume gateway, we do have some inline reduction of the data, but with file gateway, we don't. Because again, we want those objects to appear in the cloud and you can just use them straight against S3 rather than having to use our service to get back at that data.
Is it really becoming that you're replacing the volume gateway with the file gateway?
No, we see both as kind of complementary, again, depending on what customers want, whether you want file-based or block-based storage. They sort of serve different purposes, different use cases, depending on what people need. We'd have to look at a use case to see which would fit, but both complement, I think. And again, there's a reason there's SAN and NAS, right?
You had said earlier that if we destroyed the gateway and then brought it back up, our files would just show up if we use file gateway. If we use volume gateway, does that work the same way, or?
So destroyed's a really bad word, but yeah, if you were to lose the gateway, somebody fat fingers and deletes the VM, for example. Yeah, true of volume gateway also. So the way that volume gateway will work is we're constantly taking recovery snapshots of the volume on the back end, and so if you were to lose that VM and fire up another volume gateway, you can get back at that volume data that's been uploaded to AWS through either a recovery snapshot, which is going to be a crash-consistent version if there was data in flight, or actually we allow you to do volume cloning now, so live cloning of volumes, so you could pick it up as a volume clone as well. So same deal, like if your data is in the cloud, it's totally accessible to you if you were to lose that on-prem VM.
In the cross-region diagram, you copy the S3 buckets, the files to the S3 bucket in the another regions. How much latency is it, and is the file encrypted in the S3 to S3?
Sorry.
Moving the data from S3 to S3. You show the cross-regional.
Cross-region, yeah.
Yeah, and S3 to S3. How much latency is it? How much?
So that's going to be down to S3's cross-region capability in terms of their ability to move data. I'm not sure whether they publish SLAs. It's obviously going to depend on, so at some point there's a speed of light challenge, right? If you're moving data halfway around the globe. I'd have to defer you to somebody in S3 to answer what their latencies are, but I don't believe they publish an SLA today for cross-region. I think their tagline is something like most objects replicated in an hour, but it can take up to 24 hours. We have one more over here. They're going to give us actually they might not give us the hook. This might be the last session. So.
So you mentioned with the appliance, is there any access to that? So say we wanted to use like a executable like BBCP that does parallel file copy for large files. Would we be able to install that? Because it needs to be installed both on host and
On the hardware appliance itself?
on the hardware appliances. Or do
So
we
that's
have
not
that?
something that we provide at the moment. It's certainly something that we've talked to customers about, and we've heard ideas that they've had about, well, what else can we do now that we have this hardware appliance? One of the things we want to be a little cautious of is, one of the value points of the hardware appliance is that guaranteed performance that we don't always get with a virtual appliance. So as we start to think about adding capabilities, we want to understand how that could impact and how that could change that dynamic, if you like. But it's certainly something we've heard from customers about, the ability to sort of put custom pieces of their code or even run other services on top of that box. So it's something that we're actively looking at.
Yeah, and so as a follow-up, obviously, any VM images that you would use on like some on-prem VMware solution or something like that to run a gateway as a VM, is that also as closed, or are you just installing a piece of software?
On the hardware appliance?
No, on a VM in your on-prem data center.
Same thing. You should think of that as sort of a sealed appliance.
Yeah, that's what I thought.
We
Just
don't.
wanted to make sure.
There's no user serviceable parts inside. If
Okay.
you like, we provide a console to do network configuration, but other than that, once it's activated, you manage it all from the AWS console. All right, thank you guys. I hope you've had a fantastic week here in Vegas, and I hope you come back next year.